So this is the solution to assessment 4. As with previous assessments, it's valuable to attempt a problem first before looking at the solutions. Inside of this assessment, we show how to build a low-level Node.js server that queries a third-party API to get data. And we do this without using any third-party packages. So we go as close to the metal with regard to the Node.js's sort of built-in APIs. Okay, so the tools that we'll need we'll need a editor for JavaScript. We'll need the Node application, and something new, we will be using a HTTP debugger called Insomnia. Okay, and this will allow us to test our HTTP queries before we convert them into code. And that way we have this sort of separation of logic between Insomnia, which will control our HTTP logic, and then our VS Code application, which will type up our JavaScript inside of. So that way, if we have an error inside of our logic, we can catch it over here very quickly. And then if we have a syntax error, we can look more deep into that and see and know that the query should theoretically work. Okay, so it allows us to separate that. So the software libraries that we'll be using the HTTP package. This is to set up our server. We'll be using the HTTPS package. This will be used to query third-party APIs, the Spotify API that we're using. And most third-party APIs that you'll be using use HTTPS, which is HTTP over Transport Layer Security. And if you want to communicate with HTTPS, you have to use the HTTPS library. Okay, but otherwise they're pretty much the same. They have almost identical methods. The reason I don't set up a HTTPS server on our application is mainly because I don't want to deal with, like, if you're setting up a server, HTTP is very straightforward. Doing HTTPS is more complicated because you have to deal with certificates. And then we have we have two sort of helper libraries, file systems just for I/O. This is because we want to write caches and stuff. So because we want to write files to we want to write a cache file, then we're going to need an FS library. And the URL library, we're going to be working with URL data, so we need to extract that data out of the URL. And the URL library is probably the easiest way to do it. And finally, we have the query string library. This is going to be useful when we're sending data out, because some of the data that we send out is going to be, it's going to need to be converted into a query string format. Okay, and if that doesn't really make sense, we'll explain it as we go through. Okay, but inside of this assessment, you were not allowed to use anything that you could find on NPM. Okay, and for most of this class, I want it to be very sort of pure. So allowing third-party libraries that sort of abstract away the complexities that I'm trying to sort of teach in this class is not allowed. Okay, so things like express or requests are not allowed to be used. Okay. So we can start over here. We'll jump back up to the HTTP debugger later. So to create a server, we use the function http.createServer. And that has a callback that returns back two variables, request and response. So in fact, we have it over here. We create a server. Okay. And then our server, we can listen for a connection. Okay, so our server itself has a event called requests, and when a request is received, we can call a function. In this case, we call it the connection handler function. And this event passes us two streams. We have a request, which represents the request, and a response. Okay, and this is sort of our link back to the user. If we want to send them something, we can use res.end to send them something like any other stream. Well, in fact, we'll say, in fact, like any other sockets. Okay. So request itself represents the message that we received. And we can look at special properties of this, like the URL. But this is just also a stream wrapper. Okay, so for the first thing that we're going to be doing is we're going to be creating a HTTP server, and looks like we're sending back just a message, hello world. Okay, so that's res.end. Hello world. Okay, so it's res.write hello world and res.end. Okay. And so when we run this program, notice that our server has two events, one for request and one for listening. So when we start listening for connections, the first message will pop up immediately. Okay, so it's now listening on port, and the port that I specified was 3000. I can go to a browser and type in localhost 3000, and I'll see the message hello world. Okay. So we should see two requests inside of here, which we do. Okay. One, the first request is for the root of our site. And the second request is for a particular resource called favicon.ico. This is automatically made by the browser. Okay. And it sort of represents the icon, okay, in the top corner of your browser. So over here, I have a old one from a different cached example, but basically it'll try to look for this favicon.ico automatically. Okay, so next it tells me to kill the server. And make sure that every time you change your code that you do restart the server. Okay, so right now we have a way to sort of deliver messages to someone who's visiting our sites, and the process of routing allows us to segment our traffic. Okay, so essentially over here we have 1, 2, 3, 4, 5, 6 routes, okay, which we have to segment our traffic in. So I'm going to rewrite this. And in fact, another shortcut that you can do is, instead of doing res.write and then res.end, if you just want to send some data and then close the connection, you can just do res.end. So the first one is the root of our site. If someone visits the root of our site without supplying any additional information, then we want to deliver them if requests.url matches the root of our site, then we'll deliver them something. Else, if request.url matches the favicon, okay, that matches favicon.ico, then we're going to deliver them the image. Okay. Else, if the have a request for the banner image, we're going to deliver a different image. A request for an asset inside of a directory album art. Okay, so this one is our first sort of generalized version. We need something that begins with album art. And to do that, we use a function starts with, which is built into the strings prototype. So we can say request.url dot starts with, and then we'll use /album art. Okay, and this will return true if the URL starts with album art. And then we have a page request for search, which again will use the same technique. That starts with /search. Okay, so that segment, we're missing one more. We need a catch-all. Okay, so deliver content using pairs of res.writes followed by res.ends. For each of these, use the replace the text with replace with home, replace with search, and so on. Okay, so res.end. Okay, so we're putting in some placeholder text over here. Again, you can do res.write followed by res.end, but if you just do res.end, it'll do the same thing. It's essentially a write followed by end. So let's run this. Okay, so if I go to localhost now, we'll see replace with home. If I do localhost slash favicon.ico. Okay, so it's getting an error over here because it's trying to interpret it as a favicon, which it's not. But let's try some of the other endpoints, and then I can sort of show you how you can sort of force it. So over here for search, it'll say replace with search. If I say dog over here, it'll replace with 404. So these image formats are going to be problematic because they are they're trying to be interpreted based off of their file extension. So if I don't have so we can do album art. In fact, album art doesn't have a file extension inside of it. So if I said something like album art /hello, then this would not be interpreted as an image. But if I did hello.jpg, then it's going to try to interpret it as an image. Your browser is going to try to do it. So you can force it not to by doing something like res.writehead, and then you can say the content type is text/plain, I believe. And so if I do each of these over here to each of these, this will tell the receiver that to treat the results as plain text. So let's restart the server. Let's see. So invalid status code content type. I think I might have a typo somewhere. So let's content type. Oh, okay, so it needs to be status code followed by objects. So slightly off of the syntax. Okay, so let's see. Okay, so over here I'm sending back a status code 200, and I'm saying that the content type that is being received should be treated as plain text. Okay, these should be colons. There we go. Okay. So what I'm sending back is a response code 200, which means that the request was successful, and the content that you're receiving should be interpreted as plain text. So if I run this, even though that this has the extension hello.jpg, I gotta run the server. So start the server, and then if I run this, even though the extension has a JPEG extension, it is now treated as plain text. Okay, so in fact, I can go over here to replace this with images/banner. And we'll see that it says replace with banner image and the favicon as well. Okay. So these are typically called MIME types, which is a multimedia formats. Okay, so for the root of our page, we're going to be delivering this document that I've already prepared called main.html. Okay, the only thing that's really important for this is that we know that there's a input for them to type in something, and that input has the property name, which uses a value artist. So when we want to catch the data that was sent out, you use the name property, and so we're going to be catching on the name artist from within our JavaScript code. So we want to deliver this document to the user. Okay, and so we can do that by opening the file. So we're going to do fs.create read stream, and we're going to put in HTML /main.html. Okay, so we're just going to point it to this file. So it's not fs. It's fs.create read stream. And so what did I name it over here? So that's going to be named, I guess we call it main, and then we just, so const main is equal to that. We write our head. Okay, so I don't want this to be interpreted as plain text. If I interpret it as plain text, which I'll show you in a bit, then it's going to display the tags, the actual code, like this, which I don't want. I want it to render as a web page. And so that should be interpreted not as plain text, but as text/HTML. And again, that's just another MIME type. There's just a big list of different MIME types, which you don't really have to memorize. You can just sort of search as you find that you need them. So I'm going to use res.pipe. Okay, so this is a stream, and I'm piping a new stream, which is the main. So the pipe method is a method of the readable stream. So in fact, let me double check. I have this back, which should be main.pipe. So main is my readable stream, okay? And then it's going to pipe to the location that I'm writing to, which is res. Okay, it's easy to sort of mix these two up. But know that the read stream should always be on the left-hand side. So I'm going to run this. Okay, and we're going to go to the root of our site. Let's see. Okay, so I'm missing the FS library. In fact, this should be FS. I don't know why it's called. I think I know why. So that was probably just something with VS Code where it changed one, changed both of them. So let's try that again. All right, okay. So now it's delivering the web page. And again, if I change this to text/plain instead, it'll render the code, which is not what I want, but I do want to show you that this is what happens if you leave it as text/plain. Okay, then I'll get this back, which is not actually what I want. So I'm gonna change that back to HTML. And we'll run that. Okay, so we'll get our browser page. So next we need to, next we are going to pipe the icon, favicon.ico. And so that's going to be pretty much the same. We can use this as our base. But the only thing that's going to change is the MIME type, which is image/xicon. And then the path name, which is images/favicon.ico. But again, we're just delivering data. Okay, so we're gonna, I guess, what do I name this? I guess I'll just call it favicon. And it'll be favicon.pipe this. And similarly, oh, I put it in the wrong spot. So it should be here. Okay, and then we also have to do it for banner. So we'll call this one banner. Res.writeHead. The content type for the banner is, let's see, the content type for the banner should be image JPEG. Right, there it is, image JPEG, and there's an E inside of it. Okay, so that's looking good. So I'm going to test out these three before we go any further. Well, I mean these two before we go any further. We've already tested this one. And so I'm going to test it by typing in favicon.ico. Okay, so there's my favicon. In fact, it appears over here. I'm not sure if you can see it, but there's a circle with two A's inside of it. Okay, and then when I visit this site now, it should be consistent. So also because the code inside of main.html, because this code has a image tag that points to the banner image, when I make a request for localhost 3000, what's going to happen is the web page is going to start parsing this document from top down. And then as soon as it hits this image tag, it's going to send off a request to the server. It's going to send off a secondary request to say, hey, do you know where I can find this image? And because I do have code over here that delivers that image, okay, because I do have code over here that says, oh, you want this image? Let me open the stream for it, and then I'll pipe it to them. Because it delivers that image, then it's able to fill in the image into here, and it will display the banner automatically. So your browser does a lot of sort of automatic requests. It automatically gets the favicon if you visit a site, and if once it receives an HTML document, it begins parsing it, and if it hits something like an image tag, then it will automatically download that image and place it into the spot. I believe this also works similarly for other resources like audio and video. Okay, so next is the album art. Okay, so to service this request, if we see something like album art slash this long file name, then we need to check to see if this file exists. Okay, and right, this wasn't a problem previously because banner and favicon will always exist. But it's possible that they send a request for an image that doesn't exist. So over here inside of our example, the album art, I have two sort of test images. Okay, so we want to make sure that these load, but if I try something like test 3, then we should have some type of failure. Okay, so right, so this is the code that does it. This will create a read stream based off of the URL that we were given, which will be contain something like /album art something. And then if we could receive an error, which means that we couldn't open that file. So we essentially we're trying to open a file. And if we can't open that file, then we send back a 404. But if we could open the file, then we can convert it to an image and then pipe the results. So we will do this. And the location is going to be, so I need this dot in front of it to represent the current directory, and then there's a slash. Otherwise, I believe on Unix machines, it's going to go to the root of your computer. So if you don't have that dot in front of it. So I'm saying in the current directory, look for a file request that you based off of the image requests. And we're going to call that image stream. In fact, I think this can be a const because we're not really changing it. The error itself, we're not actually looking for a true error. We're just checking to see if this fires, because it'll fire if the image, if we try to read something that doesn't exist. So we have an error, then we're going to send back a 404. So we're going to send back 404. I don't think the content type really matters, but in the example, I have content type text/plain, so I will follow that. And then you can send any type of sort of request out. So we're going to so this notation, I use this notation over here to show you. This is going to be a very common notation where we have a asynchronous function, res.write, and then we have a callback afterwards. What do we don't want to do afterwards? So this will guarantee that res.write occurs first, and then res.end occurs next. In this scenario, I believe just having it like this also is correct, it'll work. But this way is more explicit that writing happens first and then the end function happens next. Okay, and then we also have to listen for the ready event is emitted when a stream is ready to, let's see, the stream itself is ready, is finished preparing to be. So the ready event is emitted when all the data has been loaded. So with image stream.onReady, we've loaded data and we're going to send it to deliver image. We're going to deliver it, we're going to call it a function deliver image. And this one will not have an error. We're going to write a 200 OK and a content type image/JPEG. And then for this one, because this one is an image, okay, so we have a stream already. We're going to pipe that image stream of image data to our response. Okay, so essentially we have another sort of bridging over here. Does the URL create a broken image? Okay, so if so, deliver 404. Otherwise, deliver a 200 OK and the image. So we can try that now. This is the file that we wanted. So it's going to be called albumart/test1.jpg. So let's fire up the server. So it's going to be albumart and then test1.jpg. So we get the first image. Now let's look for test2.jpg. And then test3 we know doesn't exist. So we get back a 404 not found. Okay, so that's good. So all of that is taken care of. Next, we need to deliver the form to the user. And that's probably going to be the same as this one. Delivering the form to the user. Let's see. Okay, so right over here we are only extracting out the user information. We're extracting out what the person typed in. Okay, so that's going to be our first step. So we need to extract out what the person typed in by using the function. We're going to be using the URL package. Okay, so specifically this class says that we can use new URL. And the first parameter of new URL is the URL that we care about, request.url. And because this is a partial URL, I'm going to try giving it this second parameter, which is called the base. Okay, and this one is required if we give it a relative URL. So our base is going to be localhost 3000. Okay, and so that's going to be our URL. I guess we'll call it we can just leave it as is. So the URL object itself is going to have a search parameters property. And then inside of that search parameters, it's going to have a get method, which is going to allow us to get the property name that we care about from the URL, which is artist in this case. Okay. And we'll test this out by using console.log on the artist to see if it prints out correctly. And then we do have one more that we need to replace with 404. We can use the same one that we used previously. Okay, write the head 404, content type text plain, res.write 404 not found. Okay, so let's test this next block of code that we just did. So we'll start off with the root of the site. And when I fill out this HTML form, okay, it takes me, the action specifies where we're going. So the endpoint that all this data is being collected to and sent to is going to be called the search endpoint. Okay, so that's this code over here where we catch that data. Okay, we put it into a new URL object. And from that URL, we extract out the search parameters named artist. And we just print it out. So I'll call it hello. And let's see if anything happened here. So, okay, so this is saying invalid URL. So in fact, I think the host that I did is not good. So I think it's missing a protocol. So let's try this. Okay, so now it does work. So it was just missing the protocol. So the request I received has the artist hello, and then we extract it out and print it over there. So this is fine. Okay, so the next sort of phase of this project is using a REST API. Okay, so you need to create a Spotify account in order to proceed. Over here, I have one that I created already. You go to dashboards, you log in. Okay, there's typically some app. If you haven't created one, you can create one. So over here, I've created one. And then inside of here, we have sort of settings. So we have our client ID. Okay. I'm going to put this client ID into my credentials file. We have a credentials.json file, which has your client ID and client secrets. So I'm going to paste this one in. Okay. And this client ID is used to identify your application. The client secret acts as your password. And for the most part, you should not be like me, and you should not sort of expose your client secret to the world. And this can have serious consequences if your API is attached to a credit card or something. There are many horror stories of people who upload their code to GitHub and then have their client ID and client secret also accidentally uploaded, and then people sort of abuse their accounts with various APIs. So over here, we have a button to show the client ID. And so this will work during this current demo that I'm running. And then when I finish the demo, I'm just going to reset the value. Okay. But for now, I'll just leave it the same just to minimize problems. But again, typically try to protect your client secrets unless you're working with someone and they would and they're part of your team. Okay. But avoid sharing the client secret with people outside of your project team, because that client secret itself allows them to impersonate your application. So they can impersonate this application with that client secret. So the difference between client ID and client secret is client ID only identifies your application. It doesn't sort of prove your ownership. So you can give the client ID to various other people, which we're going to see later. Which you may see if you do a OAuth example, okay? Because inside of an OAuth example, you have to give the client your client ID, so that they can say, "Hey, I want to use this app." Okay, client ID and client secret over here, you can think about this as username and password for your application. Okay, so in order to tell someone to use your app to sort of log in or something, then you have to specifically give them your client ID to say that, hey, this is the identifier for my app. And then this client secret says that is essentially saying that, hey, this secret nobody should know except for me. This proves that I'm the owner of this client ID. Okay, so with the client ID and client secret, I'm going to be putting them inside this credentials.json file. And I want to pull the data out almost immediately. So I'm going to create a file. So I don't actually care about the credentials. I care about the two properties inside of here, client ID and client secrets. So I'm going to use client ID and client secret over here. And so this is a destructuring assignment. And the file that I care about is credentials.json. So it's going to be require so it's going to pick the current directory of/credentials.json. And if you give it a JSON file into the require statement, it will automatically parse that object and return back an object. So it's going to return me back this client ID and client secrets. And then that will get destructured by client ID and client secret over here. And then we can use it. Okay, so we store the credentials inside of a file off. Don't share this file. The next thing we have to do is we have to follow the Spotify's client credential flow. Okay, so client credential flow is one of the authorization flows, and so there's three sort of layers of using an API. We have the API key, which was the easiest. Instead of our previous demos, when you use API key, all you have to do is attach the API key to all your requests. With the client credential flow, it's slightly more complicated. You have to take your application has to give the client ID, client secret, and grant type to the Spotify API. The Spotify API then returns back an access token, which gives you a certain amount of time to use their API. In this example, I believe it was 3,600 seconds. And then we are going to trade in that access token. So we're going to take that access token that it gave us, and we're going to attach it to all our for future requests up until that time limit. So this access token sort of essentially does represent these three values. Okay, so we have client ID, client secrets, and we need to, let's see. Right, so what we're trying to do is our server is going to be sending the client ID and client secret, as well as the, in this case, it needs the grant type as well. Okay, different APIs will need different things, but if we boil it down to just absolute minimal, you need the client ID and client secrets, and then they'll send you back an access token. Okay, once we get that access token back, we can use it for 1 hour, and then afterwards we just request a new pair of access tokens. Okay, so the API, each of these APIs is going to have an endpoint where we can send a request off to. So the request over here says we need to send it to the API/token endpoints. In fact, it needs to be a post request to this entire URL. So it'd be accounts.spotify.com/API/token. So before we go into code over here, this is where we can start breaking out Insomnia because we need to test this request. So the request, the structure of the requests is as follows. First of all, it's a post request. So to create a new request, you can go onto the sidebar over here and just click new requests. Give your request a name. Okay. This one should be a post request. The API endpoint is https://accounts.spotify.com/API/token. And then typically your APIs will be broken up into different sections. The three most common sections are body parameter. Okay, over here we have body. Header parameter. Over here in the fourth tab we have header. And then sometimes we'll have query parameters. Okay, typically these three are the most common for REST-based APIs. And you need to follow the structure. So if it tells you that grant type should be inside the body, then this is going to be inside the body. Okay. Over here, it says the body of the form post must contain the following encoded parameters in application XWW form URL encoded. So this is part of the OS specification. It says that if you're making requests, it has to be form URL encoded. So if I go to body and I click on form URL encoded, what that's going to do is going to add a new header inside of here. That's going to be called application/XWW form encoded. In fact, if I do this instead, so one way to do it is to go to body and then go to form URL encoded. That will add that header over here. Okay, so I'm going to get rid of that. And another way that you should be able to do it is to add that in directly. So that is going to be our that is going to be our content type. Okay, so as soon as I added this as a content type, let's double check one more time. Okay, so either way is fine. So you can either type it in or click through form URL encoded. Now, it's important to know that each of these properties must be named exactly as is. So even though it's got a dash over here, when we translate to code, we have to keep the same structure. So so you can't rename it. So make sure that if you're using content, if you have a dash, you enclose it in quotes. Okay, and over here it says that grant type should be set to be client credential. So that looks like it's just a constant if we're using client credential. But this goes into the form body because it tells us that it should be in the body of the post, which is this form over here. Okay, finally we have a header authorization. And this one is a bit trickier. This goes into the header fields. because it's specified as header. And over here it says base64 encoded string that contains the client ID and client secrets. This field must have the formats authorization, basic, followed by the string. And this can trip up a lot of people because the syntax must be exact. And so I've given you the code. This is a slight variation of it, where it pulls the credentials from the JSON file, client ID and client secrets, and then it creates a buffer from the specified data, okay, client ID and client secret, and then it encodes it using the base64 function. Okay, so in fact, if I run this, well, in fact, let's run it from here. So the code is saved into a file test.js. And so this is what it's going to give us back. Okay, so again, the requirement was that first we have the keyword basic, which we have over here, followed by the base64 encoded string. That base64 encoded string includes client ID, followed by a colon, followed by the client secret. So essentially, this is the full conditions that we needed. And I'm going to paste this into Insomnia. Okay, and then that finishes my requests. So if I send off the request now, if I was successful, I should get an access token. Okay, so we get this access token. Tells us that it's going to be valid for 3,600 milliseconds. And there are other sort of keywords like bearer and token, bearer and scope. These are not really particularly interesting for us. Okay, so again, make sure that inside of Insomnia we have grant underscore type, client underscore credentials, and then inside of the headers we have content dash type with capital C, capital T, and then that's going to be application XWW formula encoded, and authorization is this long string with the keyword basic in front of it. And depending on the API that you're using, this will vary widely. Okay, so there's no guarantee that a different API will want something completely different. Okay, they may want a completely different structure, and most of these are arbitrary, based off of what that API designer was trying to do for this application. So because we were able to run this, our next step should be to translate this code, translate this Insomnia output into code. So I'm going to call a function request access token, and we're going to pass in the artist information that we've extracted. So we're not going to use this directly right away, but we need to sort of pass this forward, as well as the response objects. Okay, so this function request access token doesn't actually need these parameters, but because this is sort of the second stage of our application and we need it in the third stage, we need to sort of pass forward these variables. So I'm going to write a function request access token that takes these variables. And again, it's not going to use them directly because to get the access token, all I actually do need is the client ID and client secrets. Okay. I don't actually need the artist or the response information, but the functions later on in the line, essentially, we go back up to this diagram. This is sort of the first stage, okay, where we get the client ID and get the access token. And then later on, when we perform the search, we're going to need these artist information. as well as the ability to respond back to the user, similar to how inside of all of this previous code, we always had a res.write or res.pipe. We had some way to respond back to the user. So over here, later on, we need to be able to respond back to the user, and sort of our way to do that is to hold on to this variable res. So what we're going to see is we're going to use this pass forward style code where we have another function calling another function and another function, and then each time we pass forward these two variables until we no longer need them. So inside of request access token, we need to extract out. What we need to do is we need to get the client ID and client secrets according to the Spotify structure. So we need to have headers. Okay, headers should be content type application X triple W form URL encoded, and authorization, which should be basic followed by this long string. And this is the base64 encoded client ID and client secret. Okay, so this is the base64 encoded client ID and client secret. And then we should also have a form body. So I'm going to create, I'm going to extract out the buffer data. And we can use that, we can use the code that was supplied over here to do that, where we extract that client ID client secret, and then we apply the base64 transformation to that. So over here I have similar code. It's pretty much the same, some slight syntax differences because we, instead of encoding it directly over here, I pull it from the credentials.json file. And in fact, that should have a semicolon. But I can move that over here to extract out client ID, client secret from credentials.json, and then apply the create a buffer from that information, and then convert that buffer into a base64 encoded string. And then finally, we append the word basic in front of it. So that is going to be the authorization. So instead of printing it out, I'm going to create a variable headers. And headers, again, we need to follow the Insomnia structure. So headers is going to be content type and authorization. So authorization should be this value. And now content type has a dash in front of it. And then objects, you're not allowed to have that dash because it's treated as a subtraction symbol. So to get around it, we can always encode our key values as strings. So that's what we're going to do. Okay, so now we have content type, which is application form URL encoded, and authorization is basic. And then we need to do the post data as well. And for this one, it is grant type client credential, but this is treated as what we call form data, which is application X triple W form URL encoded, which in essence means that if we look at the timeline over here, it should look something like this: grant equals client credentials. And if there was more properties like A and B and C equals D, okay, then there would be this ampersand at the end of it with the secondary properties. And this is a special structure of data called the form encoded URL data. And we can also call it query string. And to get that structure, to convert an object into a query string, there's a function query string.stringify. Okay, and all this does is takes an object and converts it to query string. So for us, we're going to create an object that has properties grant type set to be client credential. And then we're going to convert it to string, and that's going to be our post data. So we can very quickly just test that. Okay, so we get grant type equals client credential, which is what we want. Okay, so we've got the header, we've got the post data. The next thing we need to do is the token endpoint. So the token endpoint is the URL. And also make note of the method, because post is not the default method. Get is the default method. So if you want to use post, we need to be more explicit with our call. Token endpoint. Okay. And we're going to create our requests. Token requests. So to create the request, we use the method https.requests. And if you're going to be using the HTTPS package, you need to include it, which I've done up here already. Okay. Using the HTTP itself only allows you to make HTTP calls if you want to add that layer of security with the TLS. It requires you to have the HTTPS package. So that's why we sort of have both. So the HTTPS.requests structure is the first parameter is the URL. And that's going to be our token endpoint in this scenario. The second parameter is the options object. Okay, and the options object is going to contain the two components that we need are the method and the headers. So in fact, we can be a little bit more concise. I would probably put it over here. I would say options is equal to an object that has properties header and method. So method should be posts, and the headers is what we have over here. So you can also do the same thing by putting an inline object over here. But this, for me at least, is a little bit easier to read. So we can sort of see the properties of this object right away and add or subtract anything as we need it. So once we have that, to send the request off into the internet, we need to use well, before we send it off, we need to determine what's going to happen when we receive a response. Okay, in which case I'm going to catch that response. The return value is going to be a stream. So we're going to have this function receive token execute when we receive a response. And that function itself is going to process a stream. So I can call it token stream. Okay, and we'll make changes to this as we continue on. And then once we have all that set up, we can send off the request using the token request.end. So just like a standard socket, I can use .write. And then I can close the connection because I don't actually need to send anything else. So I can say, so write some data, and then when it's finished, close that connection. Okay, so in the data that I want to write, in this case, is post data. Okay, but I've already said previously that if you want to do a write followed by a closing, then you can just simplify that down to just doing the end. And that is the same as doing a write and then immediately upon receiving acknowledgement, closing that request. So we can do token request at end to close that connection. So what the instructions gives you is very similar to what we have over here. We have a additional function, stream to message, that converts the stream that we're going to receive over here, we call it token stream, into a actual message. Okay, and over here I call it post authentication callback. I guess either function's probably fine. Over here I have a error handler. I can add that as well since I'm. So what happens if my request times out? And I'll just use a inline function error, throw error. Yeah, the rest of this looks pretty much similar. We need to add this function stream to message as well. And so what this function does, okay, conceptually is that it's what we call a higher order function because it takes in as one of its arguments a function. And so what it does is it takes the stream data. So this stream data is data that comes intermittently. Okay, so it's going to keep on sort of coming in. We might get a couple of bytes at a time. Each sort of segment of data. So you can think of it about this with regard to TCP. You can think about it as one sort of chunk of data. Every time we receive a chunk, we append it. We append it to this variable body. So every time we receive a chunk, we do body plus equals chunk. So we sort of glue it to the end. And then when there's no more data, a end event fires. And at that point, we call this function and we pass in that string of data that we received. So essentially what it does is it takes a stream of data that might come in. Let's say it comes in 1 byte every 10 seconds or something. Okay, it comes in very slow. Or maybe it's like 10 bytes every second or so. Then because it's coming in slowly, it's collecting inside the body. And then finally, when all the data is collected, then the callback is executed only when the data has been finished. And how do we know when the data is finished? When we receive an end event, when there's when the system on the other side says, I'm done sending. And at that point, we move on to the next stage, whatever that stage is. Okay, so I'm gonna function stream to message. And this structure over here is less than ideal. I would add a third parameter. If I were doing this now, called args. And this notation over here is called a rest parameter. And the idea behind it is that inside of here, let me see if I can have it. Inside of this code, I need to pass along variables in the future. I need to pass along the artist and the response variable. And the drawback to this is there doesn't seem to be a construct over here for me to pass forward those variables. And maybe I do add it. Maybe I hard code it later on. Yeah, so it looks like I hard code it over here. So I say receive off, and then I attach in the user input, the uh, authorization sent time, and the response. And I would rather it be part of the stream to message function where I can sort of pass those variables forwards. So that's gonna show you how to do that as well. Looks like I got an error over here. There you go. Okay, so that's interesting. I guess you can't return a throw statement. Right, so back to stream to message. So another thing about stream to message is that it only works with strings because we have to append to the string. So if you need to do something like binary data, then you're going to need a different function. This one doesn't work for binary data. So take that stream. When we receive an end, we're going to receive a chunk. So what I'd like to do is take this args variable and so essentially what I can do now is I can say stream to message of some stream, the function to do next task, and additional variables like, so in our case we had artist, we had response, we might have date, some date variable, okay? And what's going to happen is the rest of these variables, this is why this is called a rest operator, are collected into a single array. Okay, so these three variables become the array args, which looks like this. So if I do something like console.log args over here, it would print out this. Okay, now there's a different way to use this variable as well. If you do ... of this array structure, this is called a spread operation. And essentially what it does is it removes the braces, okay, and turns this into a comma separated list. Now, the issue here is this is not correct syntax in pretty much any language. But imagine that I had some function like this, f of this. Okay, now this actually does look like a correct function call or stuff. So what's going to happen when I use the rest operator over here? This one is the rest because it's inside of the function definition. But when it's inside a function execution, then it becomes the spread operator, which operates in the reverse. It takes an array. Okay, it takes an array, which in our case was this array, and it removes the braces. Okay, so in essence, what it's doing is it's executing this callback, but it's passing in 4 parameters. So it allows me to, writing the stream to message function this way, allows me to essentially forward these variables to the next stage. And this is sort of some of the powerful features of being able to work with higher order functions, that I can take the variables and forward them to the next function call. Okay, so that would be how I would write this function now. And we'll see some slight differences that writing the functions like this does. I think it's mostly beneficial to write it like this because we no longer are dependent on some of what these variables are. I don't care if I need to add additional variables to here later on. I don't need to sort of change it everywhere, because this will forward as many variables as I need to. Okay. So we are going to, when we receive a response, that response is going to be a stream of data. Okay, and I'm going to convert that stream of data, okay, into a message. And then I need a callback to execute afterwards. Let's see. So in fact, let's move this function into here, because this function receive token isn't really right. What do I actually receive back is a receive token stream. Okay. And in that case, I can take that token stream and then immediately convert it to a message using stream to message. And then get to decide what I want to do next with that. And so afterwards, I'd like to call a function receive token. Okay, but this is just a one-line function that calls another function. So we can shrink this down. We can cut this down. Into a function. So it's an inline function over here that calls stream to message. So when we receive a response, it's a function that receives a stream. Okay, so before we called it receive token stream, and then we're going to take that stream and pass it into stream to message to convert to a message. And then when we're finished, we're going to call a function receive token. And then receive token is going to have a token inside of it, as well as any other parameters that we decide to include. So at this point, we can include additional parameters. So the additional parameters that we need to include are artist, res, and inside the code, we have a third one, which is offset time. And so this is going to be used for caching. So in fact, I think it's best for me to skip this for now. So we'll just in fact leave it out. And then when we get to the caching portion, we'll come back and add it on. But artist and res, I can sort of make an argument for why we do need these. And again, that it goes back to that sequence diagram that we had, where we are currently in this stage where we're taking the client ID, client secret, and we're sending it to the API. We're going to get an access token back. Okay. Once we finish this stage, the next step has us querying that API. And the things that we need to use are the artists, the search type, and the access token that we get back. So we need these two variables in order to progress further. The artist in order to do the next stage of this results, and then the res, because we have a third sort of request over here. I think I show it much later down the line. Right, I showed it somewhere over here where we have a client where we need to send back a response at the very end. That's what the res provides us access back to the client. So we need to forward these two variables, and because we structured our stream to message function the way we did over here, I can just pass it in as additional arguments, and these two get collected into args and then fast forwarded over here, which then appear over here as artist and res. Okay. And that way, the way we do it, again, it keeps stream to message very clean, in comparison to what I would say this version of stream to message, which is slightly messier because it's got one function that calls another function that calls another function. So we have sort of like 3 layers of functions, and over here we only have 2. So this one is slightly better because it's just stream to message, give it receive, call receive token when it's finished, and pass in these 2 variables to get forwarded to the next stage. So first let's test this to make sure it works. Console.log token. And in fact, this should be called token object because I don't think this is a token. I believe this is a token object that includes wrapper information like the expiration time and other sort of meta information. But let's run this. Okay, so we get back a token. Right, we get a token with other properties inside of it. So inside of this token, we have the token type is bearer, the expires in, and we have some scope information as well. So expires in is going to be useful for us because essentially we're going to need to cache this token. If we make subsequent calls to this API, we want to make sure that the token is still valid. So the idea behind it is that over here inside of this call, before we call this function request access token, this is a lot of work. Okay, so this has to do, let's say that this is very computationally expensive, or when we query this API, it costs us money or something. But if we have a existing token and it's guaranteed to be good for the next 3,600 seconds, then we can skip this portion. And that's where this caching comes into place. If we have a cached result already, then we can skip a lot of this by using the cache results. Okay. And I think our function names are pretty accurate at this point because basically if we put something like if cache exists, then we can skip the request access token portion. Okay, so we'll go a little bit further before we go into caching. We're going to go that way. We can we're going to the stage after caching, which would, I mean, the stage where after we start using this token to generate the next requests. And once we have that, we'll go back to caching because that way we can skip essentially this. The 2 things that we want to skip are request access token and receive access token. Once we are past that, we can go back and build the caching because essentially what the caching does is it allows us to skip this round trip. Okay, so the token that we care about is token object dot access token, and that we can just pull out from here. And we might as well also grab the, no, that's fine. So we'll just leave, we'll grab that as our token. And on the next stage of the application, so we'll come back to this caching. We'll create the search. So over here, we need to create the search requests. And so the search request is going to have us supplying the query parameter, which is going to be artist equals some artists, type equals album. This is always going to be album for our project, and then access token. Okay, so it looks like if I check the documentation, the authorization, the access token goes into the header field called authorization. And then the other parts go into the query parameter. And so the search request, the endpoint is search, and it's a GET request. And so let's look at this one. So this would be the structure of it. We have authorization followed by some access token. So in fact, this one probably won't work right now because the access token is no longer valid. Right, the access token has expired. Okay, so I need to generate a new access token. And in fact, I can use the one that's just printed out over here. This one should be good for 1 hour. So I can copy that, paste it into here. So I'm going to replace the word bearer with this one. And then if I send this off again, now the search works fine. Okay, so that's how the access token works in this case. So the type of search over here is an album search. The query is for an artist. And we are going to sort of generate this again. So for the most part, the structure of this is going to stay the same. So in fact, I'm going to create a new function. Okay, and we can call that function, what do I call it over here? Perform search. Create search requests. Okay, and this is going to essentially be the same as this, but with certain information. So the easiest way to do this is to take this as the existing one as a template. Certain things do need to get changed. This has to be get instead. The authorization is changed. It's no longer basic, it's bearer, and it's the access token. So instead of base 64 data, we're going to pass forward the access token, as well as the other two variables, artist and response. So access token gets used over here. This is not form data because you can see that the body is pretty much empty. It's a query type request, so we don't need this. And for get requests, let's see. So in fact, this method doesn't need to be supplied. It's a get by default, but I'll leave it. This is the endpoint. There is no post data, so I'm going to remove that. This I'm going to change to be search endpoint. And I will change each of these as well. Okay, we have an error message in case something doesn't work. We have a what do we do when we receive response? And I will remove this function. Well, we'll leave stream to message. We can change this to be search result stream. It's a bit long, but it's fine. And then we have receive search results, which will create it as well. We don't need the artist anymore. After we perform the search, that artist information is no longer necessary, but we still need the res variable, which acts as our link to the other user. When we're sending the request off, we can use end over here. Now, another way to do this is to use the function https.get. Okay, And the key difference between https.get and request is that request will create the requests, but it doesn't send it off until you send the end method. Whereas if you use get, it will send it off automatically, and you don't have to um, manually send it off. I believe also if you're using get, it automatically defaults this value to get. I don't think you can change it either. So for now, we'll test it with request, and then I'll change it to get just to show you how to do it with the get instead. Now we're missing the query. And inside of Insomnia, when you do a query request, it gives you the URL preview. Okay, but the structure of this we should know in general, how it works. The basic structure is the endpoint, okay? First the endpoint, then a question mark. A question mark denotes that there's data. And then for each piece of data, it's encoded as a query string. But that is all appended into a single URL. So when you send a post request, let's say that you're typing in a credit card number for a payment system, that information, you don't want to encode it inside of the URL. So that's why it's sent via post. It's sent in the body of the message. Whereas with a search request, then you don't really care, and you might want to have it inside the URL. For instance, if you want to share your search results with someone, okay, then having it in the body of message makes the data very difficult to share. But having it in the URL entirely makes it very easy to share. So there are sort of benefits and drawbacks. But the structure itself is the URL followed by a question mark, and then the data encoded as a query string. So we're going to structure that. This is going to be our search endpoint, but we need to append data to it. And so the data, in this case, the query, const query, is going to be in this case, the artist and the album. Okay, so type is going to be album. Type equal lowercase a, and Q is going to be artists. And that's going to be the variable artists. Okay, because it's the artist that I'm searching for. So it looks like you can also put this inside the query, but it looks like the recommended option that they put is to put the authorization inside of the header field, which we've done over here. So I guess either one works. In fact, let me test to make sure that this is still working. I think this quote is throwing me off. Yeah, so this still works as well. Okay, so I would recommend that you follow the official documentation. That way, if they change it later on, such that this way no longer is supported, your application doesn't break. Okay, so we need to create this object, which we've done over here. And then because I mentioned that this is going to be a query string, so we're going to use query string.stringify to get it into the query string notation, which is, again, just a bunch of pairs of key equals value separated by ampersands. So this one, I'll call it search query. And then our search endpoint is going to be equal to the search value with a question mark to denote data, followed by the search query itself. And then that is going to be our endpoint. Our options are over here. And then we're going to send this off, and then we need to have a function to catch the response. And so we receive back a stream, we apply a stream to message to it, that converts that into a text, Let's see. In fact, I think we might need to, there's one thing I forgot. So over here, this thing that we get back is clearly, obviously JSON, but it's not formatted JSON. So if it's formatted as JSON, meaning that if our operating system understands that as JSON, then it should print out colored, but it's printing out as white. So it looks like it's only interpreted as plain text. So what I do have to do is parse it first. So our token object needs to be parsed, and maybe this is not the greatest name for it anymore. And in fact, I guess I can just skip the intermediate step. So we'll do JSON.parse token object and then .access token. And I guess that's fine. I still don't like this name because it's not an object. It's a string, a serialized interpretation of this object. And it might cause confusion. So maybe serialized token objects. I just want to be very explicit that this is a string and it's not an object. So we have to parse it into an object, and then we can access the access token. Maybe token string would be better. Yeah, I'll just leave it as is. This seems okay. It's too long, but it's fine. And then over here, we need to do the same thing, serialized search objects. And we'll print out the search results to make sure that everything's working. So the stream that we receive back, we can call it search result stream. Search result stream passes it into stream to message. That'll create a serialized search object, which is just a piece of text with all the body message sort of combined. And then afterwards, we call this function receive search results, and anything afterwards, in this case res, should be pass forward. Okay, so let's test this, and then we can move forward after that. So after that, if this works, we can go back to caching. So in fact, because this one is sort of still loading, it automatically sent a request off, but it looks like it works. So, right. So over here we get back a search results. All these objects essentially are the representation of each of these. So we have album, href, items, and then instead of items, it's just an array of a bunch of albums. So it looks like we did get the results back. And so the next step is going to be caching. So essentially what we want to do is we want to be able to, so if you look at how the code is structured, essentially we're jumping from stage to stage. We start from within the search results function and we jump to receive access token. From here, we jump to, let's say, request access token. And then from here, we jump to receive token. And then from there, we go to create search request. And then from there, we go to receive search results. And then etc. And for caching, we would like to fast forward this. So we want to go from over here would be sort of the best place. We want to check to see if an access token exists already. And if so, we don't need to request the access token. I'm a big proponent of having these functions do exactly what they say and nothing else. Okay. So request access token should only request the access token. And over here we have this sort of, the only sort of leakage that we have of that is the next stage function that we have over here. And even that can be mitigated using more higher order functions, but I'd rather stay away from that because that's going into that's sort of, it's going to add a lot of complexity to add that on. And even though inside my personal projects I would definitely do it just to get this function more and more pure. At some point it becomes very difficult to read if you have tons and tons of callbacks that functions, passing functions, and so on. So there's like this sliding scale of how readable that you want to sacrifice the code in order to get it more pure. Anyways, so what we're going to do is we're going to check to see if the, let's see, we're going to check to see if the access token exists. Okay, we're going to check to see if the access token exists first. Well, first we'll write the access token. Okay, so what we're going to be writing the access token is after we receive it. And the value that we give is going to be called, the function is called create access token cache. Okay. So when we receive the access token, we're going to create an access token cache from it. This is going to be done asynchronously because writing this cache doesn't actually help our current application, but it helps our next application. And then this one is also going to be done asynchronously because it's a sort of setting it off into the internet. So both of these are sort of executing asynchronously. Okay, so writing cache and generating the search requests. And so this one is pretty straightforward. We just do a fs.write file on to the location here. Okay. So we'll do fs.write file. The location is going to be over here, auth authentication response.json. Okay. In the future, I might move it to this function, this folder cache or something, as this isn't really related to that, but it's fine as is. And what we want to encode is we want to encode the cache objects. Now we do have an issue in that this is the, let's run it very quickly and print it out first so that you can see the issue. So in fact, let me comment this. Yeah, so in fact, if we need to get out the date and time, it's probably better for us to just call this thing token object and then do access token. Because I need to look at the token object itself right now. Okay, so over here we have the token object, and we can see that it has an access token, token type, and expires in. And this is where we're going to have problem because this is just a integer. So this tells us how long that token is good for. And essentially what we want to do is we want to store the information about when this thing expires. But this is not useful to us because we write this number, if we write 3,600 into our cache, when we open it up 1 hour, 10 hours, 100 hours later, it's the same information. So this is not good enough. We can't just store this number because this number will not change. Instead, we have to calculate the current expiration date based off of this number, and then we have to store that into our cache. Okay, so we can't just store 3,600 because if we store 3,600, it doesn't actually change over time. So instead, we calculate the new expiration. And this is where we are getting into the portion of what date and time do we use. So inside of the request access token, when we're making a request, we're going to add another variable. So we're going to add another variable. We'll call it token request time. And this is going to be the current date. So essentially, this is when I'm making the request, right before I make the request. So I'm going to create a new date. And then when I send that request out, when I receive a response, it's guaranteed the expiration will be at least during this time. Okay, meaning that if I get it back immediately afterwards, okay, we know that we have a very, how do we say it? We have a very conservative estimate. We'll expire the token even earlier than that. Okay, so we might actually have 1 or 2 seconds between when this actually expires and the token is actually still valid for a little bit of time, but we expire it early anyways. So I'm going to pass this into the function over here, which means that it'll be forwarded over here. And then when we receive the token, I'm going to pass this into the token request time. And then with these two pieces of information, I'm going to calculate the new expiration. Okay, so the new expiration, and in fact, the best way to probably put this is to put it inside of the object, because this is already a object. So I'm going to put expiration. Token object.expiration is equal to token request time. Let's see. Token request time dot it's going to take the token request time, which is a date time object, and I'm going to add the expires in. Okay, so I'm going to grab the token objects that expires in, and this has a underscore. Okay, so I'm going to take the token objects that expire in this property. I'm going to add it to token request time. And this value is in seconds. And this value will convert it to milliseconds, add it to the token request time. That will be the expiration. So in fact, let's test this out by printing out the token object to make sure everything's okay. Okay, so Friday, December 11th. This doesn't look right. So it's got this number appended to the end. Token request time. Let's see what the instructions give us. I think they give us a function get time or something. Get time. Okay, so we'll do dot get time. That will give us the current milliseconds, and then based off of that, we can do new date. Grab the current time in milliseconds, add in the new wait time, create a new date based off of that. Let's try this. Expiration 2020, December 12th, 21:42. That looks about right. Okay. So this one looks much more correct. So now we have a token object. So we just added a property with the expiration in front of it. And I guess I could test this out even further by just printing out the current date and time. Okay, so the current is 20 and the expiration is 21. So that's good. Okay, so we're going to use the fs.write file to write this new token object. but we can't write an object. Okay, and this is, we need to serialize it. So we need to choose the format to serialize it. We can use query string, we can use JSON. We need to choose some format though. So we're going to use JSON.stringify, parse, in order to convert this object into a string. And then later on, we will undo this process with the parse function. Okay, so if this is done successfully, we should have a new file inside of our auth that contains this expiration data. Okay, so what are we missing? Callback must be a function. fs.write file. So the first parameter is the path. The second parameter is the data. Okay, so the third parameter. Okay, so it's missing a third parameter. Okay, so it's missing a third parameter, which is I think the options parameter is optional. And then the fourth one would be the callback. Again, it looks like the callback is required. But we don't actually need it to do anything. So I'm just going to put in this over here, which is just a function that does nothing. I guess you can like write a message over here. Access token cached. Okay, what should it do after it finishes the caching? Okay, so we have our access token cached, and over here inside of our auth.res, we have that data, which has the access token, the bearer, expires in, scope, and expiration. And then now we can go back to our code, and we can, inside of here, we can do that conditional requests, meaning that we only request if our access token is expired. So what we're going to do is check to see if it exists. I think I have the code over here, so I can just copy directly if it's given to me. I'm going to collect token cache. So we assume that the cache is bad unless we find it. So let cache valid equals false. And if the cache exists, then our token object is equal to require. So if it does exist, then I want you to open it. In fact, I'll call this token cache file. And then if the date of the, in fact, let's call this one cached. Try to call it the same, but I don't think it's helping me in this case to call it. Right, I think it's better to call it cache token, even though it is a token object. If the token object's expiration is greater than the current time, so it's going to expire at, let's say, December 10th at 2 o'clock, and if it's December 11th, then it should be, it's no good. So, but if it expires on December 10th at 2 o'clock and it's December 10th at 1 o'clock, then it's still good. So if the cached expiration date is larger than the current date and time, then that cache is still valid. And then we have a function if cache is valid. If the cache is not valid, then we're going to make a request for the new cache, for a new access token. If it is valid, then we skip this function. We skip this function, and we immediately go to this function, create search requests, because we can pass in the access token, the artist, and the response. So this is what I mean by you can sort of fast forward the operation. We're skipping all of this. Okay. So we're going to pass in the cached token object. And in this case, it only cares about the access token. So I'm going to remove the wrapper around it. So I'm going to remove the access token. This removes the expiration and all that information inside of it. Call it access token. We have artists from here, and we have res from all the way up there. So we have these three properties, and we can call create access token. That will sort of fast forward us to there. So cache exists and is valid. Okay, so that allows us to skip requesting an access token. And if either of these failed, then we just get a new access token and we are on our way. And the benefit of this is we essentially get a almost unlimited efficiency boost if for that 1 hour. So meaning that we only requested the access token once, and now if we have 1 million or 1 billion queries, we don't need to get a new access token because it's good as long as we use it within that 1 hour. Okay, so let's run this. So cache exists is valid, and then it makes the requests. Again, this is just automatic because of this browser. But if I force it even still, then the cache exists and is valid, and it skips a bunch of those functions. Okay, so the next step is we need to take those search results and we need to go through them one at a time. So essentially the structure of the search results is that it's got it's a JSON file. It's a very large JSON file, and we need to essentially go through each of the properties. So this is the entire, in our case, search results object. And so the first thing that we're going to look at is that it's composed of a property called albums. So we would say search results dot albums. And then inside of that, it's got several components. And the one that we are interested in this case, is items. So it tells us straightforward when we search for a particular album, there's, in this case, 1,114 albums. And it's going to show us them 20 at a time. If we want to look at the next 20, there's a URL for the next set, but we only care about the first 20. So that in our case is items. And this is an array. We can tell by the square braces, and it's probably got 20 items inside of it, each one representing a single album. Okay, so this is an array, so we're going to use array notation. I'm going to stick an I inside of here for now because most likely we're going to need to loop through each of them. Each of them represents a single album, and if we go back to the top of our project, we can see that we need to display all of them, or all 20 of them in this case. And so we're going to need to do some type of looping structure to loop through those items. And then inside of each one, what do we care about? Well, all we actually do care about is the images. Okay, so each album has 3 images. It's got one that's 640 by 640, one that's 300 by 300, and one that's 64 by 64. Okay, and so we'll probably use this one, the middle one, but it actually doesn't really matter which one you choose. So how do we get to that one? So it's going to be items sub images is the next property. And then images is an array. Okay, but this time we don't need to loop through this array, because if we loop through this array, we're just putting the same image in 3 different sizes. And as I said, we want the middle one. So that's going to be, this is 0, this would be 1, this would be 2. So we want square base 1. And then inside of here, this is an object. And of that object, we care about the URL property. So essentially, this is us traversing the search result object, which may have hundreds or thousands of results inside of it, depending on which API you're using. And this is another nice feature of Insomnia. You can take that object and you can traverse it to find out what data that you need. So I'll create a loop. So I'm going to take each of these images and I'm going to create a new array from them. So what's the best way to do this? So essentially, this one, we care about the length of this. Okay. So I'm going to call this one albums. Okay, because this is the one that has multiple results inside of it. And I will do albums.map. So map is going to apply a function to those results. I'm going to call each individual one album. So take each result, call it album. And we can do album, and it's going to be .images square brace 1.url. Okay, this is going to return back each of the URL images. Okay, and let's do that. Console.log album art URLs. So let's try this. And this dot map items. There we go. Okay, so this gives us back an array of each of those album arts. And if we were using a loop, it would look like this for let I equals 0, I is less than albums.length, I plus plus. And so we would have album art URL is an empty array, album art URL dot push, album images of 1.url. Okay, which is slightly slightly messier, I would say, than just having a nice map function. But both of these would be the same. So we have the array of album arts. And then our next request okay, so we want to get these URLs, which we did. And then the next request is to make the request for the images. And because each of these images may be different quality, maybe they're stored on different disks on the Spotify servers, maybe like these 3 are on SSDs, and then the rest of these are on, let's say, archive drives that are slower, then we might receive them back at different speeds. So we don't really care about this. We just want all of them back as fast as we can. So we're going to do this asynchronously. Okay, so we're going to schedule each of the downloads asynchronously. And so over here, we have some code that does that. Over here, we use the https.get method. This works because the request to download an image is just a get request. Okay, so over here, we have the URL. In fact, you don't even need any authentications for this particular endpoint, and they've designed it to let it be public. So if we sort of send the request out, we can just get that request. So essentially all we have to do is send a get request for this resource. Okay, so I'm going to, let's write a function. So we'll write a function download image. And then that's going to take a URL, which we'll pass into over here. And what I'd like to do is to take each of these album art URLs and map the function download images to them. Now, the issue that we have here is this download image, we need to know when all the images are finished downloading. So over here we have a counter downloaded images plus plus. So we need to have something like that. And the problem that we have is that if we pass in a variable downloaded images over here, then this variable is going to be set at the time of this function call. So it's passed by value variables. So inside of JavaScript, primitives like integer or primitives like number are passed by value. And so if we want to pass a reference, we need to convert it into an object. So in fact, we have to do a bit of a workaround to say downloaded images is an object downloaded images and so even though we want just like a counter or something, we need to wrap it inside of this object. And if we don't, then essentially what we're going to be passing in every time is a bunch of zeros. Okay, so essentially we want to pass in, we want to have it pass in this reference to this variable. So we create a variable over here, download images. It's got our property count, which has the value 0. And then we're going to map our album art into this download images function. And we're going to pass in a reference to this download images variable where we'll increase the count. And again, if you just did something like download images equals 0, that's not good, because what's going to happen is each call of here is just going to pass it in 0, and it's not a reference to it. So this is sort of how you do pass by reference inside of JavaScript. You turn it into an object. Okay, so over here we're going to download a single image. So it's https.get the URL. And when we call https.get, we actually don't need to use the .end. If we use request, we need to do a .end. But over here we don't. And there's a callback for when we receive a response, but we can also do that. Let's see. Image requests. In fact, we'll change this to const. Most of these should be const as well. This one should actually be that. Actually, I think this one can be const as well because the object doesn't change. Let's see what happens when I change this to const. Image request is equal to https.get followed by the URL. Image request dot on response. So what should I do upon receiving a response? That would be this function over here. Now we can't use stream to, before we use the function stream to message over here. And because this is binary data, we can't use that over here. So we have to, in this case, manually do something else. So what I do is I create a file stream, and then we pipe the result to that image. So in fact, we'll do a inline function, and if it looks really bad, we can move it to a separate function. Receive image data. So I'll give it a function name, even still if it's inline. So we know that this is a stream. And we need to create a new file stream. I'll call this stored image. fs.create write stream. And we need to pass in the path and the encoding. So the path will be, we have to set up the path as well. The path will be based off of the URL. It'll be the file name from the URL. So we'll do some manipulation on the URL that we received to extract that at the very end. And I think we can just do new URL based off that URL. And then based off of this URL library, we should be able to extract out, we want the path name, it looks like. Let me double check over here. We want the path name, and then we want to extract out only the last file name. Is there any way to get out the very last file name? Friends, ABCXYZ. It looks like path name is going to be our best bet, and then we just remove from the very end. But if we have to do that already, then there's no point in using this library. So if we have to do that already, yeah, there's no specific file option. So we'll just do so this is a string. We're going to split on the slash symbol. And then temp. So essentially we're tokenizing. It's string split function. This will tokenize on a specific character, tokenizing on a slash. which will give us back an array. And then what we're going to do is we're going to extract out the elements at the very end of it. So it's going to be temp square brace temp.length -1. And that would be the very last string. And so what can I call this? Tokenized URL. And we'll call that file name. File name is equal to tokenized URL. And then we remove the last bit. So a lot of students, sometimes they change this into something else. They change the file name, and that's problematic because it's not guaranteed to be unique. This is guaranteed to be unique. So we're going to use this as our file name. And so the path, the image path, is going to be equal to album art and then the file name. And we'll add a .jpg at the end. So I'm not 100% sure this file formats, but I'll just guess that it's JPEG. So we're going to make a request for that image. That's going to be we're going to write it to this location. And our encoding is going to be null. So because we don't want to treat this as text, our encoding is going to be null. And I'm not sure, is that the default? Let's look at fs.createWriteStream real quick. So it looks like the default encoding is UTF-8. So we do need this. Okay, so do be very careful, because if you use the default UTF-8, it'll try to write this as a string, when in reality it's binary data. Okay. And then what we need to do is we need to take that request and pipe it to a file. So we get back a response over here. That's going to be a stream.pipe. So it's readable.pipe, and it's going to be writable. This is our writable stream. So this goes into stored image. Okay, so that will write the stream. And then we have a way to detect when it's finished. So when this stream, in fact, maybe I'll call it save image. So the finish event is the same as the end event, but it's only used for the writable streams. And what I want to do is download images. .count ++. And again, I need to have this as an object, because if it was just a primitive, then it would be passed in as a 0. And then because this is essentially a loop, the next time it occurs, this would also pass in a 0. And instead, I want the reference to here. So I need to pass in a object. Matches albums.length. And in fact, this will be... So I need to pass in the length of the albums in total. So I guess the best way to do this is to add in a different property over here. Total images. Or just total is fine. And we'll set that to be equal to album art.length. Okay, so if this is, in fact, we'll use bigger equal, just in case. Then we go into the final stage where we generate the web page. So in fact, let's print out a message instead for now. Okay, so this will print out a message. We downloaded a new image, followed by the images that we've downloaded. And then when we finish, we do the generate web page. So let's test this. Okay, so, oh yeah, that's just because this prints out down here instead of up here. Oops. That's why we get the 20th out of order. But we have these are some weird results. Who did we search for? Oh, we searched hello, that's why. Okay, I guess that makes sense. Let's search for someone else. And again, I didn't restart the server, so it's still running the old code. So, all right, okay, so this is much more expected. So that is fine. We can download the images. I'm not 100% happy with how messy this code is. This goes on a bit more indenting than I'd like. But I'll just leave it as is, as extracting out these into specifically their own functions can take a bit of time. So essentially what this does is it downloads images and it calls download images several times, as many times as the number of URLs that we have. And because this is essentially a loop, each of these gets completed as soon as possible. We have a counter. Okay, so we have counter that is created up here, and it's a counter of 0. In order to pass a counter into a subsequent function, we have to treat it as an object, because instead of JavaScript, variables are passed by value, but objects you can pass by reference. So this counter inside of it, when we pass in download images, it's always referring to the same download images variable, so that when we increase this counter, it increases this sort of shared variable. And that's how we are able to have multiple sort of asynchronous tasks share a single variable. Okay, and let's see. So what we need to do next is generate the web page. And the generate web page is pretty straightforward. All we need to display, we need to take the results and send it back to the clients. If you notice from our code over here, we've lost that res variable, so we need to pull it back. So it looks like we lost it over here. So essentially, we just need to pass it forward into this function. So this goes into download images, and then if it's the lucky one that sort of survives this check, essentially we've split our execution into, if we have 20 images, 20 paths to download all 20 paths, and only one of these will have the download image count be bigger or equal to download image total, which is the very last one that finishes, in which case we'll pass the res forward. In that case, every other sort of thread sort of dies off. Okay, and so inside of this response, if we look at the very top, we need to display, it looks like we need to display the search results. Let's see if I can, believe we need to display the images as well as the artist name. So we need to, in fact, pass forward the artist name as well. Okay, so we have the artist name up here inside of a heading. So I guess that would be our search results. So we need to go back again to find where the artist was last used. And we will pass this artist forward as well. Okay, so we're going to generate a web page. And to generate the web page, we just need to take each of the images that were downloaded. So we need to take each of the images that were downloaded, and we need to, so essentially we need the image data, and the image data, the URLs, were inside of the array So it looks like we should create an array to store the images data. And in fact, that will likely allow us to eliminate the need for this object entirely. So I'm going to call this image metadata because it's about the images. And so every time we download an image, every time we finish downloading that image, we're going to pass into that array we're going to pass into that array a new record to say that this image has finished downloading. And the path to that image is such. And the only thing that we have to worry about is how do we encode this number? Because image metadata can replace count, okay, because it's 0 and it'll go up each time we finish downloading an image. So that'll replace count. Is there any way to replace this total variable with image metadata? When do we stop downloading? So it looks like we can't. And so the best way to do this, in my opinion, would be to replace count with an array. Downloaded images, which will have the image data. We'll call it images. And then it will be the total, the number of images that need to be downloaded. Okay, and then this time, instead of using count plus plus, we just push to downloaded images.images. So downloaded images.images, push that image path, that increases the length, which is our new counter. And then if downloaded images.length is bigger or equal to download images.total, then we move on to the next stage. And we can pass in the artist information as well as all the image URLs. In this case, the image path URLs. So let's print this out. So in fact, I only need the URLs at this point. I don't need the total images. So I'm going to print out the image URLs and see if I get that. Okay, download images, and I get undefined because that was printing out the number before, and there's no longer this number. So instead I can print out the path information instead of this counter, which no longer exists. Okay. And then we have the array of images over here, so we know that that's good. So the last thing to do is to combine these into a single web page. And so that web page is the structure of that web page is going to be each of these album art images is going to be enclosed in, it's going to look something like this. And then I want it to have in front of it, so in front of this I want img space source is equal to a quote and another quote. So in fact this will be album and then over here will be that. Okay, so I need to loop through these image URLs. In fact, I'll call this image URL singular. So going to loop through these, return an array of all of these, take each image and return that, then combine them with the empty string. I think the default join is there's a comma separating it, which I don't want. And then in front of that, we can do res.end of a heading with the artist information, and then the results. So I don't like using backticks instead of backticks. I guess that's fine. I'll call this the body of the page, or the image portion. And then we'll have a header in front of there. Okay, so this last res.end delivers the artist information as well as the image components, which is all those image links. And so what's going to happen is the user is going to get delivered an HTML document that looks like this. So in fact, let me use res.writeHead. The best way to sort of show you is to use res.writeHead and to send this as plain text. Okay, so we're going to send it as text/plain. Okay, so the browser is not going to render this document. Okay, it's only going to display it as plain text now. Image URL is not defined. Okay, looks like it's good. Why this display as right head? It should not have displayed though. Oh, I didn't do the content type. Let me go back up here. So I messed it up. So I didn't actually want it to display. So I need to use this one, content type plain text. So this is what I wanted. Let's try it one more time. Okay, so this is what gets generated. Okay, so it's the heading followed by each of these image tags. And what's going to happen is when the browser, if I don't set this to be text plain, but either use the default, which is it'll use the file extension to interpret it, or we can use content type text/HTML. Okay, so it's going to see that these are HTML tags, and then it's going to automatically make a new request to our server. And then our server will catch these requests over here. And for each one that it catches, it will send a response back. That'll say, here's the image that you wanted, here's the image that you wanted, and so on. And then as those images get received, it's going to sort of plug in where those images should be displayed into the documents. Okay. So did I change this back to text/HTML? I didn't save. So there you go. There you go. Okay, and now the albums are actually displays. And so let's see, that covers most of the project. I think the rest of this is adding additional caching. Okay, so before downloading an image, check your album arts to see if you have the image already. And if so, serve that image first. Use fs.access for the tests in this case. fs.access is better in this case because we can do it asynchronously. Before we use the exist sync function over here, so we use the exist sync function over here because we can't proceed further. Essentially, if the access token exists, okay, then we want to go inside of here. And if the access token doesn't exist, we want to know before we request the access token. So we do specifically want to wait. So in this sort of area, this blocking nature is helpful. Whereas in the image example, okay, in the image example, we may want to meaning if we're checking to see if image 3 is cached, then that shouldn't prevent us from downloading image 5 if we know that it's not cached. Okay, so can we do that with our current structure? So this is one of the sort of drawbacks to having a bunch of arrow functions over here, in that if I need to add this in, my current guess is I need to split up this arrow function into something more traditional, like a standard function, because it looks like essentially what I want to do is inside of here, before I download the image, I want to check to see if I have it cached. Okay. Let's see. So we have the image path, which would be over here. So I'm going to copy these 3 lines of code just for now. fs.access. I want to check to see if this image path exists. And if it does exist, I don't need to call download images. If it does exist, then I need to call download images. So it looks like we want to check to see if this file is readable. And it looks like this is the syntax that we should be using. So it's a constant, ROK is readable OK. And if it's not, even the readable is probably not so good. Let's do this one if OK to just see if it exists. Okay. Okay, so it looks like this callback will check to see if that file exists. And the existence of it is dependent on whether or not this error is true or false. So if error, if it does not exist, right, if error, then the file does not exist, then in that case we want to download the image. Otherwise, we don't download the image. And we execute this function over here. We add this to our array. Image is down, image is cached. If downloaded image.length is greater than or equal to the length total, generate the web page. So you can see that we have a little bit of duplicate code over here. That's just because I'm coding this live, and should I come back to revisit it, I would definitely sort of clean up some of these. So we can test this. I'm not 100% sure if this is right, but let's delete some of these album arts, but not all of them. Okay, we want some of them to be still there. And hopefully, essentially, it'll say that this image is cached, this one is not, this one is not, and so on. Okay, so let's say that some of the images are cached and some of them are not. So we make those requests. Okay. And then our server, after it downloads is all these images, or the ones that it didn't download, were cached, then we send off the results to the user, and then they make the results from our page. And so I think that covers most of the project. The only sort of little bit left was to create the sequence diagram. And then we talk a bit about the sort of performance, but that requires that you create the sequence diagram. Essentially, it's asking you, we've cached the access token, we've cached the images. Is there anything else we can sort of cache inside of here? And there's one last request that I'll sort of leave up to you at this point to sort of determine what can we cache. Because essentially between the server and the Spotify API, every time we sort of ask for data, it gives us the ability to sort of cache this data. And caching it, we can sort of cache basically anything that it gives us. Anything it gives us, we can save it to our disk. And that can reduce the number of requests that we need to make to the API. There's some drawbacks to certain requests. And those, for the most part, can be minimized. For the Spotify access token, it's almost, there's no real drawback for this one because they tell us specifically how long that access token is good for. For the images, there are some drawbacks, okay, because let's say that they change the file name, the Spotify API, they change some content, they change the file names for their cached images, or they change the images directly themselves. Let's say that this particular album art changes or something, and I'm still using the old data because I cached it. There can be some drawbacks. So that's just mainly just asking you to test through that. And then the testing portion, I just inserted some special characters over here, like quotes, slashes, and stuff. And that's just to make sure that you are using the album art file names that were supplied to you, and you are not changing the file names to something else based off of the artist name. Because if you do that, then if you get something with weird characters, then it sort of breaks it up. So use the file names that the API gives you in most cases.